Good evening, students. I welcome you. And what we were talking and what we were discussing in the last lecture, student, the structure of the atom. And we have shown that there are subatomic particles which are present inside the atom. What we said, there are subatomic particles. And you already have seen the person who has discovered the electron, students. Who was the person who was the scientist who discovered electron, students? Tell me the name. We have discussed last time the discovery of electron. Who discovered electron, students? You are aware that we have shown you last time that J.J. Thomson discovered electrons, students, and we have shown you that there was an experiment, cathode ray tube experiment, in which cathode rays were found, students. They were moving from the cathode towards the anode side, and these particles were found to be negatively charged particles, and they were moving in a straight line. So this experiment was done by J.J. Thomson, and the electron was discovered. We are familiar with that, student. You are familiar with the name of j.j. Thomson. So as you can see, this is a picture of j.j. Thomson. He discovered electrons. As we say that there are subatomic particles, now there are charged particles which are present inside the atom, students. And certain activities were done in the last lecture to show that there is a charge. There are charges which are present, charged particle. There is a charge inside the matter, inside the atom, students. So the first to be discovered was electron. And it is important now. The question then began, what is the structure of the atom? The main purpose was, what is the structure of the atom, students? So after the electron was discovered, you know that it was also found what is the charge of the electron. Charge of electron was also determined, student, and mass of the electron. Mass of the electron was also determined experimentally. These things are determined experimentally, students. So what we are doing, we are trying to find the structure of the atom. What is inside the atom? What are the particles which make up the atom? And we also want to know, student, what is the structure of the atom? So how these particles are present inside the atom, that was a point, student. So there are many atomic models, and J.J. Thomson was the first one to give a model of the atom. Because you know that now you are saying there are charged particles which are present inside the atom. Charged particles are present. And you know, there is a discovery of the electron by J.J. Thomson, and we also shown you there are canal rays. There are canal rays, students, which were positive rays. Positive rays were also discovered, students. So the particle which is carrying a positive charge in an atom, there is a positively charged particle inside the atom also. What you are saying, there is a positively charged particle which is also present inside the atom. So you have electrons, which are negatively charged, and also you have positively charged particles which were called the canal rays. And you already know that the person who has done the experiment, E. Goldstein, 1886, in the gas tube experiments, found the canal rays. Therefore, students, now the question has been that how these, since the atom is neutral, but you know that atom is neutral. Atom is neutral, student. Atom as a whole is neutral. That means there must be equal number of positive and negative charges which are present inside the atom. Inside the atom. So the question is then how electrons and protons are arranged inside the atom. What you are saying that the atom is made up of, has protons and electrons, students. And the positively charged protons are positively charged particles, students, which we say, if this is a p is having a positive charge, and you have an electron which is having a equal and opposite negative charge. But we said that it was found experimentally the mass of the proton is about 2000 times that of the electron. What was the mass of the proton, student? Mass of proton is about 2000 times that of the electron. That of the electron. The first model which was given for the atom, that is called the Thomson model of the atom. So let us see what is the Thomson model of the atom. After the electrons were discovered, students, and positive particles were discovered, protons, Thomson was the first to give a model of the atom. Thomson, what we say, Thomson model of the atom. Thomson's model of the atom. Students, you have seen that during the Christmas, what they are eating, pudding, Christmas pudding. Actually, this has to do something with what at that time they called Chris, Christmas pudding. So they were familiar with the Christmas pudding which they were eating. In the Christmas pudding, what you have, students? You have got whatever pudding you are making, inside that you put some dry fruits. You are putting certain dry fruits, students. When you make that sweet pudding, inside that there are dry fruits which are very, very small. Uh, uh, what dry fruits? Like currants. We have seen those black type of small currants in the pudding. So from that picture, student Thomson proposed a model of the atom. And what he said, what Thomson said, since atom is a neutral, but electrons are there and protons are also present inside the atom. Electrons are negatively charged particles. Proton is a positively charged particles. So he says that atom could be considered as a positive charge of the atom consists of positively charged sphere and the electrons are embedded in it. What is he saying? This, if this is a picture of the atom which is given by Thomson, what he's saying, spherical cloud of positive charge. There are positive charges, as you can see that. What he said, that atom consists of positively charged sphere and electrons are embedded in it. Because the mass of the proton is 2000 times that of the electron. So it is just like the Christmas pudding. You put small dry fruits, you see, in the pudding. Electrons are like those small dry fruits which you are putting like currents, and then the positive charge is distributed, you see, in the sphere. So he said, okay, this is a model of the atom, student. Yeah, for example, you have seen watermelon, students, and if you cut the watermelon, how it looks. Inside the watermelon, you have red color, which you can say that is a positively charged sphere. And inside that positive charged sphere, you are saying there are the seeds which you see, the black seeds of the watermelon. Black seeds of the watermelon, they could be taken as electron, students. So you have this is something like watermelon model, what you are saying, or Christmas pudding model, and positively charged sphere and electrons are present inside them, embedded in it. And the important point is that the negative and positive charges are equal in magnitude, because that atom is neutral, student. Atom is neutral. Okay? How it can be neutral? If the negative and positive charges are equal in magnitude. There is a negative charge, you are saying negatively charged particles, which are electrons, and there are positively charged particles, students. So which you are saying protons, you have E minus and P plus. So they should be equal in the negative and positive charge should be equal in magnitude. The magnitude, what we are saying, student, the magnitude of positive charge should be equal to magnitude of negative charge. Magnitude of negative charge, so that the atom becomes neutral. The whole atom, what we are saying, atom is neutral. There should be equal and opposite charges, equal and opposite charges. And this is a picture which we have shown you here. This the first model for the atom. After electron is discovered, proton is discovered, it is clear that inside the atom you have now negative particles and positive particles, and how they are distributed, how they are present inside the atom. So a model is proposed. That doesn't mean it is right or wrong, that we have to test whether it is correct or wrong. But the simplest model, the first model, is given by Thomson, because electron was discovered by J.J. Thomson students. So there is a positive sphere and there are electrons which are present, student. But the problem with this is that what are the what was this was rejected, students, by the scientists. This model was not acceptable to the scientists. When you do not accept a model in science, there should be reasons for that. And what we say, limitations of the Thomson or drawbacks of the Thomson model. Second point, what are the drawbacks of Thomson's model? This model was rejected, student, by the scientists. They said this is not the correct model of the atom. Atom cannot be like this. We will tell you the reasons. More reasons are coming to prove that this is totally wrong. This model could not explain the stability of the atom. So the results carried out by the could not explain. Important point was that there were more scientists who were performing more experiments, students, and they found that there were more experiments which were done by scientists. Which experiments? I will tell you very soon. Which experiment? More experiments were being done by certain scientists like Rutherford, and which we are going to discuss today. Rutherford's alpha scattering experiment. Rutherford did a very important experiment which could not be explained by this model. This model cannot explain the results and observations of the Rutherford model of the atom. Rutherford's observation could not be explained. Rutherford has performed an experiment, student, which could not be explained by this model. So the observations which were obtained by Rutherford experiment could not be explained by the Thomson model. Number 1 point. As a lot of experiments were being done, these experiments were not agreeing with this model of the atom which was given by Thomson students, and also it could not explain the stability of the atom. It could not explain the position or arrangement of electrons inside the atom. It gives no information about the electrons position, where the electrons are. It only is just like a pudding model. They could be anywhere. And further, it could give no idea about the size of the atoms. Doesn't give any information that how big, how small is the atom. Therefore, students, these are some of the drawbacks which we have written. More experiments were done. They could not be explained by this. Number 2 point, it could not explain the stability of the atom. Number 3, it could not explain the position or arrangement of electrons inside the atom. Number 4, it could not give any idea about the size of the atom. You have noted down everything, students. We will proceed further. Note down what we are trying to know. What is the structure of the atom? how the particles which are discovered, student, by the scientist are arranged inside the atom. But where are the protons? Where are the electrons? Or if any other particles are there, where they are located? And for this, experiments were being done continuously by large number of scientists. And in this connection, Rutherford experiment is very important because that experiment proved that this model is completely wrong. And we're going to discuss the Rutherford experiment now. First, you note down this. Can I proceed further, students? Tell me.
Yes, sir.
Okay. You have understood that Thomson discovered electrons and canal rays were there which proved that there is a positive charge. Now the question was how these positive charge particles and electrons are arranged inside the atom. Whatever Thomson knowledge was available to Thomson at that time, he said, okay, this is the model of the atom. There is a positively charged spheres in which are present the electrons, in which are embedded the electrons, like a Christmas pudding, in which dry fruits are put inside the pudding. But more experiments were being done, especially Rutherford experiment was done at that time, and which could not be explained by this model, student. Therefore, this model is not correct. There is a need for another model. And let us see what is the other thing. Okay, then now interesting thing is that Rutherford model of atom is coming. That this model, Thomson model, is not no good, student. I am saying Thomson's model is not giving any stable atom, and it could not explain many experimental results which were done by the scientists. So Thomson model is not correct. Is not correct. Then what other model of the atom we can propose? You know the interesting thing about atoms and the electrons and protons which are present to you. You cannot see the atoms by the visible light. Why? Because the wavelength of the visible light, the light which is coming from sun, the light which is coming from your fluorescent tubes, bulbs, students, the wavelength is bigger than the atom. So individual atoms can reflect visible light. Uh, Atoms are so much smaller than the light itself. You will never be able to see any more than a fuzzy dot. Can you see the atoms by light? The answer is no. Because the atoms by the visible light, what I'm talking, can you see the atoms by the visible light? Here is a statement which is important. Individual atoms can reflect visible light, but the atoms are so much smaller than the light itself. The wavelength of light is much, much larger than the size of the atom. And what you will see, a fuzzy spot. And another interesting thing, that a human being which has a weight of 70 kg, if a person has a weight of 70 kg, there are almost, you can see, 7 into 10 power 27 atoms. How many atoms? I'm just giving a number. 7 kg person, 70 kg person. How many atoms are there? 10 power 27 atoms. See how much is that number? Very big number. Your weight is, student, 45 or 50 kg, then you can see how many atoms are there. 10 power 26. 10 power 26 atoms you are made up of. 7 billion billion. And out of that, the atoms which you are made up of, how many? 10 power 26 billion, 7 billion billion billions of atoms you are made up of. 2 by 3 is hydrogen. In this 2 by 3 are hydrogen atoms. 1 by 4 you have oxygen, and 1 by 10 of carbon, and so many other atoms, different atoms. See how much hydrogen, oxygen and carbon is present. So 99% is this in your body. Hydrogen, oxygen and carbon, 1% other. There will be other elements, you know, bones are made up of calcium, phosphorus, so many elements are present. And each atom, as further we are seeing, atoms are made up of charged particles, students, protons, electrons, and there is another particle which will be discovered, neutral particle, neutron. So there are three fundamental particles which we are talking, subatomic particles. So how much you will have in your body, electrons, protons, all these things are there inside your body. Okay, this was just a information for you, that's all. Now the question is, students, the Thomson model is not correct. And I said that experiments have been done by the scientists, and the most important experiment was being done by Rutherford. Rutherford student was performing experiments. He was performing experiments. Why he was doing experiments, students? Because he wanted to know how the electrons are arranged within the atom. Rutherford was interested to know how electrons are arranged inside the atom. And there are many other reasons also. He was performing some work on radioactivity. Radioactivity, what is radioactivity? We will tell you. Rutherford was interested in knowing how the electrons are arranged within atom. Rutherford designed an experiment for this. So if you want to know what is the arrangement of electrons inside the atom, can I see the atom? Answer is no. As I said, we can't see them. Very, very small particles. Then how do we see them? I said experiments have to be performed. We have to perform experiments, students. And sometimes we don't have the experiment, then we have to make and design the experiments. Design the experiments, students. How do I design the experiments? I cannot design the experiment alone, students. They will take the help of engineers and so many other people in designing the experiments. So Rutherford designed an experiment, and in this experiment, student, we will be showing you the diagram of the apparatus which was designed by the Rutherford. And at that time, students, radioactivity was also known. Certain elements were found to be radioactive. Radioactive elements are those, students, which emit certain radiations. You know, you have heard about radium. Radium, you say it emits certain radiations. There are so many radioactive elements now. They emit certain particles, students. So that was known at that time. And in this experiment, Rutherford used, students, alpha particles. Which particles I am saying? Alpha particles, student. And in your books, they will be shown like this, alpha particle. This is a symbol of alpha particles. What are alpha particles? We will just tell you everything in this experiment. So Rutherford, here I have shown a picture of that, is a genius because he was also given Nobel Prize and father of the nuclear physics. He is famous for his work on radioactivity and discovery of the nucleus of an atom using gold foil experiment. He is known and was awarded, students, Nobel Prize for his discovery of the nucleus. Rutherford's discovered nucleus. So the most important thing, earlier we said discovery of electron. Now I'm talking of discovery of nucleus, students. And who is doing the experiment? Rutherford and his team must be having a lot of people with him. They are performing experiment, students. So experiment has been designed by the Rutherford. Let us see what is the experiment which was designed by Rutherford, students. Let us see. Very important diagram is on the screen, students. As I said, Rutherford is interested to find out the arrangement of electrons inside the atom. So he designed an experiment. This is the setup of the experiment. What he did, student, he selected a thin gold foil. You know that gold is highly malleable. You can produce a very thin sheet of gold, malleable and ductile. Gold, most malleable. You can form a wire which is very, very thin from the gold. It's a very malleable and ductile. You can form thin sheet of thin foil of the gold. Why did he choose gold foil, students? Because there are so many elements. You will tell me, sir, there's iron is there, lead is, so many elements are there. Why he was choosing the gold foil, student? Because he can prepare a very thin foil of the gold. Gold is the most malleable and ductile, student. He can form very thin wire or a sheet of the gold. And thin layer, he could, because he wanted to have a thin layer, thin layer. Sheet, you know, sheet has some thickness. You want thin, very, very thin layer. So that it could be about 100 atoms thick. 100 atoms thick. You know, you are saying everything is made up of atoms, but there are very large number of atoms, students, in everything. How many? Very large. I just saw 70 kg man, how many atoms are there? Billions of atoms. Now you are taking gold, you want a very, very thin sheet of the metal, which will be about 100 atoms thick. Because we are going to perform an experiment, students. 100 atoms thick. And then he chose alpha particles. Alpha particles, I am saying, was chosen by him. Alpha particles are, student, doubly charged helium ions. Helium ions. Student, have you heard the name of helium? Tell me. Yes or no? Are you aware of helium? Students, tell me.
Yes, sir.
What is the symbol of helium? Tell me. How do you represent helium in chemistry? He. You have heard about helium gas? You know about that? Where it is used? Balloons, in the metallurgical balloons, etc. You have seen inert gas, helium, noble gas element, helium. What is the mass number of helium? You know what is the atomic number and mass number, students?
Sir, atomic number is 2.
And mass number is 4, students. So in chemistry, sometimes we represent it like 2He4. This is the atomic number, this is the mass number. What it means, atomic number 2 means there will be 2 electrons. What it has, students? Actually, we will be telling you it has got protons, 2 electrons, 2, because equal and opposite charges will make it neutral. And there is another particle, neutron, also 2. That is, the mass is P plus N4. We will be telling you more information about this later on. So what he did, alpha particles are doubly charged helium. Doubly charged helium means he has removed the electrons from that. What it will mean, student? He plus plus. This is a doubly charged helium. Okay, doubly charged helium ions. This becomes an ion now. You know what are ions? We have told you. This is atom. This is my helium atom. Okay. If I remove 2 electrons, student, then what it will become? Ions. So these are the alpha particles. Alpha particles are nothing but they have a mass of 4U. One atom, the mass of one atom I am saying is 4U. And doubly charged means there are 2 positive charges on it. Okay? And he used fast moving alpha particles. fast moving students alpha particles. ठीक है, got it? ठीक है, have you noted down this students? ठीक है,
Yes, sir.
where will he get alpha particles from? Here is a setup of the experiment. This experiment was designed by Rutherford. You can see I have here a box is there, and I'm saying radiation source. It has radium, student. Radium is a radioactive element. What is radium? Radium, Ra, This is a radioactive element. What do you mean by radioactive element, student? It will emit certain radiations, and it emits alpha particles. It emits alpha particles. What are alpha particles? Doubly charged helium ions. So inside this is a source which is a radium. Radium is a radioactive element. What is it emitting? Alpha particles. You can see that alpha particles are coming from this box, students. Coming? Yes or no? Can you see it? Can you see, student? This is a box from here. What are coming? Alpha. These are our alpha particles. What are alpha particles? Doubly charged helium ions. Where they are coming from? Radium. Radium is a radioactive element. It emits alpha particles. And here, this is my gold foil, student. Gold foil. How thin? Thin gold foil, which is about 100 atom thick. 100 atom thick. Very, very thin gold foil. This is my gold foil, student. Can you see the gold foil? Tell me. This is a gold foil. This one. Very, very thin. Can you see it? Tell me yes or no. ठीक है? Can you see it? Tell me yes or no. Alpha particles, they are bombarded on gold atoms. This gold foil will contain gold atoms. How much? About 100 atoms thick. What it contains, students? Gold foil. Gold foil contains what? What are present here? Gold atoms. Now alpha particles are bombarded on the gold foil, students. These are fast moving alpha particles. And alpha particles are having how much mass? 4u. 4u means they are heavier particles. Heavier particles. So it was expected that they would be deflected by the subatomic particles in the gold atom. Since you are saying inside the atom there are particles. Which particles? Protons, electrons are present inside the gold. We are already saying that there are particles, protons and electron. The mass of the proton is how much? How much is the mass of the proton as compared to electron? Tell me. Tell me, student. 2000 times, about 2000 times. So it's quite heavier. So we would expect alpha particles were heavier than protons. Alpha particles has how many protons? 2 protons and 2 neutrons. So you are saying that alpha particles are heavier than protons. Where are the protons present? Inside the nucleus, inside the atom. ठीक है? You are saying protons are present inside the atom. You are hitting them with alpha particles. So what he said ki, what will happen? This will strike with those. They will be hit by these proton particles. They are much heavier. So we don't expect very large deflections. We don't expect very large deflections, student. But what he observed? What are the observation he has got? What he found? This experiment is called alpha scattering experiment. What is the name of this? This is called, student, alpha scattering experiment. This is done by whom? Rutherford. Who is doing it? Rutherford. And what he observed after doing the experiment. What are the observations which he found? I'm saying observations. You know, in science students, what we do? You perform an experiment and then you observe. And observation you record. What are the observations? This is a gold foil, this is the alpha particle. Here you can say there is a fluorescent screen, student. Fluorescent screen means every time the particle will come, this will give a spot. Just like photographic film, you know, spots are formed, na? How you get a picture. So if particle will hit it, there will be a spot. Wherever it will hit it, spots will be seen. Spots will be seen. If it doesn't pass through it, if it is deflected back, then it will not pass through it. Then there will be no fluorescent. There will be nothing. No spots will be seen. But here some spots are seen. This is a fluorescent screen, student. You can see some spots. And see the spots. So what are the observations he found? He found that most of the alpha particle pass straight through the gold foil. But he found, student, most of these alpha particles passed straight, students, passed straight through the foil. Through the foil. One thing he observed. First thing that he observed, most of the particle passed straight, student. They are not coming back. They are passing from this foil. They are passing through this, and some were deflected. Some alpha particles were deflected, students. Deflected means you can see what is happening. This particle is going to this side. This particle is deflected. They are going straight, straight, straight. Few very small particles, they are deflected. See the deflection? And spot is here. This is a spot is here. Some particles were deflected, student, by small angles. What is the angle of deflection? I am saying by small angles, students. And what further he observed, student? What he found? 1 out of 12,000. 1 out of 12,000 appeared to rebound. Appeared to rebound. Student, rebound means, बताइए, what is the meaning of rebound? Comes back. What happens? Rebound means, what is the meaning of rebound? That if you are hitting something on at this point, it comes back. It comes back. Rebound. ठीक है? आपने बॉल मारी, वापस आ गई. Comes back in the same direction. So it is rebounding. How many? Only 1 out of 12,000. If I pass 12,000 particles, only one is rebounding. Mostly are passing straight. Most of them passed straight. What did it mean, students? And how one particle is coming back very strongly. One particle is coming back very strongly, student. Mostly are passing straight. Few are deflected. These are the observations, students. Now what conclusions can be drawn? Tell me. I told you experiment will be done. Observations will be made. After that, you will form some conclusion, students. So what conclusion can be drawn on this basis, student? These are the observations. This is the design of the experiment which was done by Rutherford. Can you tell me anything? What conclusion you can draw if I say, okay, this is the experiment, these are the observations. Now tell me, students, from this experiment, what is the conclusion which you can draw? What conclusion can you draw? Tell me. What do you think? what we are trying to look, what is how the electrons and protons are present inside the atom. We are saying the attempt is to find structure of the atom. Where are electrons, where are protons, how they are distributed inside the atom, how they are arranged inside the atom. That's what we are saying. Now this experiment has been done, and this completely disapproves the Thomson's model. We said ki positively charged sphere and inside that you have electrons embedded. Then why most of the particles passed straight, student? Most of the particle pass straight. Why things will pass? If you are, if you have a wall, student, if you are hitting it by a ball, why should it pass out of the wall? Tell me. Can the ball pass through a wall which is closed? Tell me. Yes or no? Tell me. The story is now coming to this. Supposing I have a wall, student, and you are hitting by balls. Tell me, can it the ball pass through the wall if it is closed? When the ball will pass through the wall, if there is some empty space, if I say that okay, there are a lot of holes in the, if there are a lot of empty space or holes in the wall, then ball can pass through it. Can then it can pass from this point to the end. Why will it pass? Otherwise, every ball will come back if it is closed. So you are passing these particles through atom. You are saying this is my atom. This is your atom, and you are passing these rays, students, alpha rays, alpha rays. These are also particles, heavier particles, and you are saying most of it are passing out. Most of it are passing out from the atom. They are passing out of the atom. What it means, students? What conclusion can you draw? I give you 1 minute to answer my question. What is the conclusion? Student, experiment has been done. Observation has been made by Rutherford. And what conclusion? Question is, what is the conclusion of Rutherford model? Students, can you tell me what is the conclusion? Can you think? Students, can I rub this part? Tell me. You have noted down? Noted down, students. Tell me. What?
Yes, sir.
Okay. So what is the story? How will we say, students, that that when alpha particles have been passed from atoms of the gold, most of them have passed straight. Few are deflected. 1 out of 12,000 is rebounded. So on what basis? What is the conclusion? What is the conclusion, student, of this experiment? Then what is our conclusion? What is the conclusion of this experiment? Let me say. Now the question is, what conclusion can we draw from the observations made by the Rutherford? Okay, tell me anything which you can say. First point, what it shows, most of the alpha particles pass straight, means that most of the space inside the atom is empty. You can say that most of space inside atom is empty. Yes or no? Tell me. If it is filled with something, it will come back. If you are saying okay, this is an atom and it is passing, what will pass through it? If it is empty space, then only it will pass. Tell me, yes or no? Empty space, these particles can pass. If there is something, then it will be either deflected or it will come back. Yes or no? Tell me. Right or wrong? So most of the space in the atom is empty, so particles are able to pass out of it. Yes or no? Tell me. Clear? That means most of the space inside the atom is empty because most of alpha particles, student, most of the alpha particle passed through the foil, passed through gold foil without deflection. Without deflection. They passed straight. Why will they pass straight, student? Because there is an empty space. First point. This is our first conclusion. Is it clear? Second important point. Very few particles are deflected. Very few particles are deflected, students. Deflected means they change their path. Very few. As they come here, supposing it is coming and deflected. When it will be deflected? When it will be near to a positive charge, because alpha particles are positively charged. What is the charge on alpha particles? You are saying they are having positive charge. When positive charge will pass near the positive charge, what will happen, student? It will be deflected. It will be deflected. This shows that where is the positive charge inside the atom? What we are searching for, student, where is the positive charge located inside the atom? Where are electrons located inside the atom? And now you are saying most of the space is empty inside the atom, and few are deflected. Where will the deflection take place? When positive will meet the positive. This is a positive particle. This is a positive particle. If it comes near it, what will happen? It will be deflected. Positive and positive will deflect. Yes or no? Tell me. Therefore, positive charge of atom occupies very little space. This proved that positive charge of atom, students, occupies very little space inside the atom. Very little space inside the atom. Second conclusion from this experiment. Okay? Third, 1 out of 12,000. 1 out of 12,000 rebounds. Rebounds mean it goes like this and it hits something and it comes back. This is rebound. So that will rebound only when it hits a positive, hits a proton. When positive hits a positive set point, positive hits a positive point, then it will rebound, student. And only 1 out of 12,000. All others are not rebounding, only 1 out of 12,000. What it means that? It indicates that all positive charge and mass, because it has 4 unit mass. What is the mass of this? 4 unit. What is the mass of proton? 1 unit. This is 4. You are saying helium is 4u. You have said helium. What is helium? 4u mass. Mass is how much? 4u. 4u is the mass of helium, as we write 2He4. Okay? So what you are saying? 1 out of 12,000 rebound mean all positive charge and mass of gold atom student is concentrated in a very small volume, student, and small volume within the atom. And this was called as nucleus. This was given the name nucleus by the Rutherford. Students, and this is the discovery of the nucleus by Rutherford. Discovery of nucleus. This is the discovery of the nucleus by Rutherford, students. Therefore, students, we can say that according to the experiment which has been done by Rutherford, we can put forward a model. Which model was put forward by Rutherford? That is called Rutherford's atomic model. In other words, students, what I said, see, these are the gold atoms. Student. These are my gold atoms. See, these are the gold atoms. See how many, we said that very thin layer of gold has been taken. About 100 atoms of the gold are, thickness is 100 atoms thick. Alpha particles are allowed to pass through a gold foil which is 100 atom things. Student, most of these particles pass straight. You can say the most are passing straight. And you can see that only when they will strike the positive part of the atom, they will rebound. Here this strikes the positive, this is the positive part of the atom, which I'm saying now nucleus, where the entire positive charge is present, where all the protons are present. It is deflected, when it hits it, or it rebounds back. In some cases 1 after 12,000 it rebounds back. Student, it is rebounding back, you can see. And then there, as the particles will pass near to the positive, alpha is positive, this is inside it positive charge. When positive will come near, it will get deflected. You can see the deflection. So here, students, what we are trying to show, mostly are passing straight. You see, these are passing straight 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 and few, you can see where are the deflections. This particle, student, this has deflection. Here is a deflection. See, when it comes near to the positive, when this alpha particle come near to the positive, they are deflected, student. Few are deflected. How many? Few. And here you see that it hits this and rebounds. This is a rebound. How many? 1 out of 12,000. 1 out of 12,000. So these are the atoms which we have shown. These dots are the where positive charge is positive mass. The entire mass and positive charge is located here, which I have shown by these dots, student, dots there. This is what I am saying, the discovery of the nucleus. This is our nucleus. Nucleus contains all the positive charge and mass which is present inside the atom. Mass of electron is negligible as compared to mass of the proton. We already told you mass of electron is 1 by 2,000 times that of the proton. The mass of proton is 2,000 times, about 2,000 times that of the electron. So this was the experiment which was done by Rutherford, experimental setup, and the observations and the conclusion. So from these experiments, students, we can say that inside every atom is present a nucleus in which all the mass and the positive charge is present. Positive charge is present, student. It is present inside the nucleus. So there is a positively charged center in every atom that is called as nucleus. What we are saying, there is a positive charge center, student, here. So Rutherford gave his model after doing this experiment. What he says, there is a positive charge center inside an atom which is called the nucleus, student. So Rutherford discovered the nucleus. Therefore, Thomson model is no longer true. Thomson cannot explain the results and the observations of the Rutherford experiment. And nearly all the mass of atom resides inside the nucleus. Electrons revolve around the nucleus in circular paths, and the size of nucleus is very small as compared to size of the atom. The nucleus is very small in size, student, as compared to size of the atom. So most of the space inside the atom is empty. So alpha particles will pass straight through them, and therefore the Rutherford proposed the following model of the atom, which is called Rutherford atomic model. What we are saying, this is our nucleus in which are present most of the mass of the atom and positively charged particles. Later on, neutrons were also discovered, which are neutral particles. Neutron, proton, they are present inside the nucleus, and electrons are revolving around the nucleus. As you can say, revolve around the nucleus. Electrons are revolving around the nucleus in circular orbit, students. So this model was proposed by the Rutherford. This is called Rutherford model of the atom. Therefore, Thomson model is no longer true, and there will be questions in your paper on Rutherford alpha scattering experiment. Any doubt? Tell me, any doubt, students? Do you have any doubt?
No, sir.
All right, then we will continue more about the story of the atom, the structure of the atom, and later on we will try to see, as more experiments are done, what more information we have. Is this model right or wrong, or even this model is wrong, then we have to, because this model also will be proved wrong later on. It could not explain the experimental results. I'm saying experiments are being done, they cannot be explained, therefore models are out. Then we have to propose another model, and we'll see whether this model gives an atom which is stable or not. All these problems are there, but the discovery of nucleus is a great revolution, student, in the structure of the atom. And here is a transformation, here is a revolution which brings something very important, that every atom has a nucleus in which are present positively charged particles, protons and neutrons. Most of the mass is concentrated there, and positive charge is present inside the nucleus, students. And electrons are revolving around the nucleus at a very fast speed, and most of the space is empty. We'll continue with this in our next lecture. And thank you very much for listening. Keep on sharing our videos with your friends. Subscribe the channel, as more and more important lectures are coming for learning science, for appearing in your papers and in exams. We are going to solve each and every question of your book. So continue with us. Bye bye. I'll see you in my next class. Okay. Bye bye, students.
Thank you, sir.
Okay. Thank you.